So far, we've talked about the nuisance problems associated with the industry. Now let's take a look at each step in the process and how it can negatively affect people's health and the environment in the area. First thing to be done before the drilling starts is seismic mapping. This is a process that oil and gas companies use to explore for the natural gas. The instruments called geophones are placed in the ground in a specific pattern in areas to be explored. This requires running long extension cords through the area and through people's yards and across driveways from a recording station to these devices. These cords are sometimes even put in place by helicopters in areas where there's not enough roads. Then they bring in a truck called a thumper truck to pound or vibrate the ground to send sound waves through the ground. These sound waves bounce off the different layers of rock underground and return to the geophones. Sometimes they even use explosives underground to create these sound waves. And then this data is interpreted, and this helps them determine the underground geology of the area, such as where the gas is located, how dense that gas is, and how thick the shale bed is. And then that gives companies an idea of the best places to drill. The vibrations from this process do disturb underground fresh water in these areas. This can cause contamination of water wells. It releases harmful metals and other underground substances that aren't normally present in our water in high levels. And these vibrations loosen the materials underground and can disturb the water, groundwater in these areas. And then the noise associated with this step is also a nuisance for residents in the area and can be a disruption to pets, livestock, and wildlife in the area. And that's the case with many steps in the process. Noise is almost a constant for residents in the area from this point on. And the trucks that will bring all the equipment in, the drilling and fracturing, as well as compressor stations, are extremely loud. With multiple wells in an area, residents may be forced to endure higher noise levels for 24 hours a day, 7 days a week, for years at a time. Noise from oil and gas operations has been measured at 90 decibels outside people's homes in the areas during drilling and fracturing, which I will talk about here in a moment. Once the area is mapped and the minerals are leased, the truck traffic starts. One well requires thousands of truck trips from start to finish. This is obviously noisy, damages roads, and causes dust problems on gravel roads. Many things brought in throughout the process are heavy loads. All sorts of things like earth-moving equipment, pumps, compressors, small buildings, cranes, parts of the rig, pipe, sand, water, chemicals, tanks, all kinds of stuff. Each well requires thousands of truck trips. Usually 2/3 to 3/4 of all those truck trips are fluid trucks. You will see these commonly on roads in the Fayetteville Shale area. These trucks either carry clean water, chemicals, but most carry flowback fluid that has come back out of the hole after fracking. We will talk more about this fluid later. There are also thousands of large pickup trucks as well. Here's an example of the numerous heavy loads that are required. I've never seen cattle guards damaged like this before. The Arkansas Highway and Transportation Department estimates that $455 million is needed to repair state highways, and they say that over $200 million of that is just in the 5-county Fayetteville Shale area, with the natural gas industry being a leading cause of the damage. Department experts say they have seen 20 years worth of wear and tear in just the last 5 years. This only accounts for damage to state highways and does not consider federal, county, and city roads. In 2011, they developed a plan to place new weight restrictions on 133 miles of highway. After lobbying by the natural gas industry, it was shortened to 69 miles of highway. Also, former Arkansas Gas CEO and former candidate for governor, Sheffield Nelson, has put together a plan to raise the state's severance tax to 7%. He's working with residents and groups like ours to gather the required 62,507 signatures to get the proposal on the ballot in the general election in November. Our current rate is set at 1.25% of market value of the gas produced during the first 5 years of a well's production. Then the rate goes to 5% after 5 years. Last year, the industry paid $54.6 million on the $3.65 billion worth of gas they produced. That totals about 1.5%. This is because most wells in the Fayetteville Shale produce most of their gas in the first 2 to 5 years. Then the production rate drops dramatically and levels off. Surrounding states of Texas, Louisiana, and Oklahoma all have severance tax rates of 7 to 7.5%. They all offer different types of exemptions for high-cost wells and other exemptions to allow companies to pay a lower tax rate in the first few years of production. Although the flat rate of 7% in Arkansas will be slightly more than those other states, it would still only collect a small percent of what is needed to repair roads across the state. All three of these states produce much more oil and gas than Arkansas, so even though their rates are lower, they collect much more from severance taxes, which has allowed them to keep up with road and environmental damage, as well as keeping other taxes low. Road damage is not confined to the Fayetteville Shale area, as fluid is trucked to areas around the Fayetteville Shale, to southern Arkansas, and to Oklahoma for disposal. There are also other facilities like sand mines and chemical plants all over the state that trucks travel back and forth to. However, the Arkansas Highway and Transportation Department has stated that all of the portion of the severance tax that they receive, 100% of that money does go to roads just in the Fayetteville Shale area. Having that many trucks on the road also leads to more accidents, no matter what industry the trucks are in. Residents are sometimes forced off of small area roads. Another common complaint from residents in the areas is truck drivers that drive too fast. This person just happened to have their camera in their hand when they, along with the vehicle in front of them, were forced off the road by a speeding driver that is clearly over the yellow line. Some residents in the area have tried to take matters into their own hands when truck traffic becomes unbearable. I interviewed a man in White County who was arrested for calling 911 multiple times because of the loud trucks near his home at all hours of the night and common speeding trucks on his road. Another problem from the truck traffic is dust on rural roads. This causes respiratory and eye problems for residents in the area. Some companies spray substances on the road as a dust suppressant. Companies are permitted to spray substances labeled proprietarily modified cellulose blend by the companies that sell it. That basically means it's some type of plant blend or oil that's been proprietarily modified, which means secretly modified. They're not telling you what they've added to it to modify it. Companies are also permitted to spray well cuttings, also known as drilling mud, on the roads. This is the mud, water, and oil that comes up out of the ground during the drilling process. Again, the materials brought up from underground may be naturally occurring, but many are harmful to humans in high levels. This mud also burns the eyes, nose, and throat when traveling or living near these roads. It sticks to residents' vehicles and can damage the paint. This mud is not supposed to be sprayed over creeks and streams, but often is, as is the case in this picture here. Here's a road with a sign showing a $1,000 fine for littering, yet companies have been permitted to spray their drilling mud on this road. Here's a road that has been sprayed, and here's the cattle next to it. We've driven many roads in these areas, in residential areas where people live and have their farms. Right before we took this picture, a couple of these cows actually had their head through the fence eating the grass in the ditch, and this road still had puddles in it. It was so wet from being sprayed. Would you want to live on one of these roads? Would you allow your children to ride their bike down these roads to their friends? Would you want to go for a walk down one of these roads? Companies often say that they're doing this to help the dust on the roads in the area, but we found roads that are paved, roads that have been sprayed on, which indicates that it's also just a method for them to dispose of their drilling waste. Another largely unknown problem with the process is all of the land that is cleared for well pads, roads, and pipelines. A flat well pad must be built to hold the drilling rig and other equipment used in the process. The building of the pad requires hauling in dirt to raise the land or deforming the land to make a flat pad. It may require clear-cutting many acres of land. The pad is then covered with a layer of gravel, and dust from this gravel blows in the air and washes into nearby waterways. A road must be built from the existing roads to the well pads, and an extensive network of pipelines must be put in the ground to connect the wells to existing transmission pipelines. An extensive network of transmission pipelines has already been built in this area. This may require putting roads and pipelines across creeks and streams where sediment control is often inadequate. Silt fences deteriorate and fall apart over time, and we've seen many that have failed and are not doing their job, such as these. Some are just left to rot away over time. Grasses that are also planned to control sediment runoff are often not native grasses and struggle in our climate, and therefore not doing their job. All of this deformation of land, even with sediment control regulations in place, can cause heavy amounts of sediment runoff during rain as well. 32% of the wells in the Fayetteville Shale area are within 100 yards of a creek or stream, and 81% of them are within 300 yards. High amounts of sediment can be as destructive to wildlife as a chemical spill. Only 1/10 of an inch of sediment over fish eggs can kill up to 50% of the eggs. Many places like Clinton, Arkansas have experienced high amounts of sediment in their water supply and have had to put boil orders in place. They also have high amounts of manganese. This is common around the country in other shale plays where industry activity is high. Heber Springs has also seen recent problems with high sediment or turbidity in their water. A well pad can be anywhere from an acre and a half up to about 15 acres. Most well pads in Arkansas are usually anywhere from 2 to 8 acres. Here's a pad that is about an acre and a half. Here's another about the same size. Here's the 15-acre pad that's right next to that one. And here are the 8-acre pads that are close by. You can see the extensive network of roads and pipelines that was required to be built to these pads. Here's a pad that's about 10 acres, and you can see the road that's been built to it. This forest has just been clear cut for this pad. Here's a typical cluster of well pads you'll see in the area. These may be houses with people living in them in this production area. Here's another. You can see the houses clearly in these areas. And again, remember, as we talked about the forest integration laws and mineral rights versus property rights laws, these people may not necessarily have wanted this activity here in the area, and they may not be making any money from it. Here are some of the pads on the Gus Blatt Scout Reservation near Damascus. The main hall can be seen in the photo here. One of the oil and gas commissioners is on the board of directors for the Boy Scouts. After the pad is built, assembly begins on the drilling rig. All the equipment for this is brought in, including parts of the rig, drilling pipe, small buildings, cranes, lights, and other pieces of equipment. The rig itself can be over 100 feet tall. This gives you an idea of the scale of the rig with this employee here. Numerous lights are also installed on the rig itself and around the drilling site. These lights can be a nuisance for residents in the area, and from this point on, the extremely loud process is usually done around the clock. This can make it almost impossible for nearby residents to sleep, and can even be loud enough to be disruptive during the daytime. Drilling of one well usually lasts about a month or two, but some may take up to 6 months. And with multiple wells on multiple pads in a small area, drilling may be ongoing for years at a time near residents' homes. These rigs also stick out like a sore thumb and detract from tourists in this area. Here's a rig near a popular boat ramp and fishing spot on the Little Red River. The hole is then drilled as section after section of steel pipe is attached and put down the hole. You can see an employee here loading a pipe onto a skid. The pipe is carried up, attached to the next section of pipe, and that section is then drilled down, and the process continues. Some rigs work slightly differently, but most are similar. Another common misconception with the industry is that the fracturing process is the only step in the process that can contaminate groundwater. Unfortunately, we've received numerous complaints from residents of their water being disturbed during the drilling process itself. When the drilling occurs, drilling must occur through our fresh groundwater or underground aquifers. This releases oils and other lubricants used in the drilling process into our groundwater, as well as releasing high amounts of harmful underground substances such as heavy metals and other things that are normally only present in extremely small quantities in our water. Vibrations from the drilling rig itself in this process can also disturb underground aquifers, and we again have received many complaints from people having problems with their water during this drilling process itself. The hole is drilled down to a certain depth and then stopped so a concrete casing can be poured on the top section of the well to protect the groundwater from the chemicals injected during the fracturing process. Once the casing is poured, the hole is then continued down to what is called the kickoff point, which is where the hole starts to curve to be horizontal. At this point, usually another type of drilling rig is brought in to continue the horizontal curve and the horizontal section of the well. Flexible pipe is used along with special drilling guidance, and this allows companies to drill a horizontal portion of the well for up to a mile. The sediment, water, and lubricants and oils from the hole during the drilling process are brought to the surface. This sludge is referred to as well cuttings or drilling mud. This waste is sprayed into a holding pit that has a plastic liner. You can see this white pipe that comes out of the side of the drilling rig. It travels across the drilling site to a pit with a plastic liner, where this fluid that contains harmful substances is sprayed at high pressure into this pit. The mist from this pit can often drift towards nearby homes in the area. This is a sludge that we showed earlier that's sprayed on roads in the area. It runs into creeks and streams and can also make its way into shallow groundwater where residents draw their water from. It is not uncommon to see Department of Environmental Quality reports that show holes and tears in liners. And since fences and nets are not required on these pits, it is common to see reports of dead animals in the pits that need to be removed. There was a pit in Allred that was found to be leaking fluid. It was hard for the person who discovered the leak to get any state agencies to respond. Arkansas Department of Environmental Quality eventually discovered that the company had left the state, leaving multiple pits with fluid unattended. It was almost a year from when the problem was found until the problem was fixed, and the company eventually just took the fluid to another nearby pit and filled in the pit that was leaking. Another common misconception with the industry is that drilling and fracturing is occurring many thousands of feet or a mile or more below the surface. This is true in many shale plays around the country, but unfortunately the Fayetteville Shale in Arkansas is one of the shallowest shale beds in the country. The shallowest documented gas well in the state is a little over 1,200 feet deep, and the deepest is just over 9,500 feet. In Arkansas, there are hundreds of gas wells that are less than 2,000 feet, over half are less than 4,000 feet, and over 80% are less than the mile that is often advertised by the industry. The Fayetteville Shale area is within one major aquifer and directly above another. The Arkansas Geological Survey has confirmed to us that drilling and fracking occurs within an aquifer, but maintains that water at that depth is saline and not fit for drinking. However, the aquifer at that depth is part of the same aquifer near the surface, and faults and cracks in the area make it possible for fluids to eventually rise into our shallow groundwater. After the drilling is complete, the rig is taken down and the site is prepped for the fracturing process. The remaining drilling waste is taken to be disposed of, and normally the pit liner is removed and the pit is filled in with dirt. Sometimes this doesn't take place until after the fracturing process, and the pit is used to catch the initial flowback fluid. Once the pit is filled in and the liner is removed, it is supposed to be taken shortly thereafter to be disposed of. However, we have talked to residents in the area who have seen pit liners sit on a pad for a year or two before they were actually taken to be disposed of. Once they are taken to be disposed, they're normally just taken to municipal and county landfills for disposal. As I mentioned earlier, a concrete casing is placed around the inside of the hole to a depth below the freshwater section of the aquifer, as determined by the Oil and Gas Commission. While multiple layers of casing do exist near the surface, there is only one layer of casing that is required to go to 1,000 feet in the Fayetteville Shale area. This is called the surface casing. Some water wells in the area are over 700 feet deep, and until June 1st of 2011, the 3,500 wells that were drilled before that were only required to have 500 feet of surface casing. There's no intermediate casing required in Arkansas in the middle portion of the well, and then you have a production casing requirement at the bottom of the well within the shale layer or other layer that you're trying to fracture in. And this casing must be sealed to the top of that layer to the next rock layer above that. The industry says this casing is what prevents the chemicals that they're injecting from reaching the water that we drink. This is done drilling the hole to a depth to how deep the surface casing goes, so that would be to 1,000 feet. Then they stop drilling the hole. Then they bring in large pump trucks, concrete pump trucks like this, to pump the concrete at high pressure down the hole. And that concrete comes down the hole, it hits the bottom of the hole at the bottom of the pipe, and it starts to come back up the back of the pipe to the surface, behind the pipe and the walls of the hole that they drilled. Once this space is filled in, they're only required to let the concrete set for 12 hours in Arkansas. After the concrete dries for 12 hours, they can then drill a hole in the bottom of the casing here and continue down with the hole. Again, while some other states do require an intermediate casing, which would mean the casing would go all the way from the surface all the way to the bottom of the hole, in Arkansas that's not required. Some states also require a tool to be used during the casing process that ensures that the pipe stay in the center of the hole and doesn't get too close to the edges. Holes are not perfect, and sometimes this pipe can get too close to the edge of the hole, thus leaving a thin spot in the casing. Some critical points in a casing are the seals. You have the concrete casing sealed to a rock layer here above the, for this example, Fayetteville Shale formation, and then there's a seal on the concrete on the bottom of the surface casing to the rock wall that it is connected to here. These seals are normally weak points, and the industry itself reports that most times when there's a casing failure, it's on one of these seals. If either of these seals fail, that allows the fluid to be able to travel back up out of the hole and up behind the casing very easily and into freshwater zones near the surface. This has been the cause of water contamination in many cases around the country. Concrete is not something that lasts forever. It deteriorates over time, and it can fail for many reasons. Poor materials, poor workmanship, and even earthquakes can cause the seals on these casings and even the walls of the casings themselves to fail. The chemicals that are used are highly corrosive, so this corrodes the steel pipe on the inside of the casing very quickly, leaving only this concrete to protect us from the chemicals that stay potent in the ground for hundreds and even thousands of years. There have been thousands and thousands of earthquakes in the Fayetteville Shale area over the last year or so attributed to disposal of this fluid, and it is unknown how many casings may have failed during this time period. The initial cause of the blowout of the BP oil spill was determined to be a problem with the casing, which allowed gas to flow up the hole unexpectedly, which was then followed by a failure of the blowout preventer, causing the largest and most destructive oil spill in the history of America. Halliburton was the company that performed this casing job, and they also do casings and fracture jobs in Arkansas. After the well is drilled and the casing is poured, the site is then prepped for the fracturing process. Again, this requires numerous loud and very heavy truck trips for all of the fracturing equipment. Usually 5 to 12 trucks are brought in with large pumps on the trailer and many other pieces of equipment. Water is then taken from area ponds, lakes, creeks, and streams, or is sometimes pumped from water wells underground. When these companies drill a water well to be used for fracking, this can cause the water level to drop dramatically, which dries up water wells in the area. We've talked to people whose water well had not run dry for generations until a company came in and began pulling water from the underground aquifer. Sometimes long pipes are set up along roads and through fields to carry the water from the source to the well pad. Sometimes it is pumped into a lake or a pond from a creek ahead of time before the fracturing process begins. These pipes often leak, which is taking unnecessary water from nearby water sources. If the company draws water from a water source that is on the same property that the well is on, then no permit is required. If the water comes from another property, then the company must get a non-riparian permit from the U.S. Army Corps of Engineers. In 2007, the Corps only had 17 permits on file in all of Arkansas, but by 2010 they had 1,019 permits on file. 999 of those were for use in fracking. Sometimes if the well is too far from a water source, then water is purchased from a different company and brought in with water trailers. Again, usually 2 to 7 million gallons of water is used during the fracturing process. Other parts of the well pad are brought in at this point, like large tanks and pipes. They bring in things like sand hoppers and other pieces of equipment. Cranes must be brought in again. The chemicals used in the process are brought in at this point too. Some come in smaller containers, some come in large tanker trucks. Some are in liquid form, some also come in solid form. This is a picture from a Arkansas Department of Environmental Quality violation report that shows improper storage of dry chemicals, where you can see that they're leaking out all over the ground. Chemical storage facilities exist all over the state. This one was on Highway 65 between Conway and Greenbrier. The site held numerous different sized tanks with different chemicals in them, as you can see here. It was right next to Highway 65 and directly next to a feed and hardware store, as you can see here. The director of the Greenbrier Concerned Citizen Advisory Group found that this site and another like it in the area were only zoned commercial and not on industrial property. He notified the federal EPA, and within 2 days both companies at each site started removing all of their tanks with chemicals. All that is left at this site is the building. The gravel around this site was almost black at the time they removed all the tanks. They have since then put a new layer of gravel down, and the building and property is now for lease. It can be used for a car lot or any other number of things where the public comes and goes as they please without knowing what was there before. Here's a list of common chemicals used in fracking. This list was pulled directly from an industry website. Arkansas and only a couple of other states have enacted laws that require companies to reveal the chemicals they use in fracking. However, companies can apply for a trade secret exemption, and they do not have to reveal that chemical, only its chemical family. In Arkansas, there are a little over 360 chemicals registered with the state, with over 60 of those being exempted from disclosure. No states require complete disclosure, but many of these chemicals are known carcinogens and known endocrine disruptors. There have been no studies on the health effects of these chemicals when they are all mixed together. The industry always points out that only about 1% of their mixture is chemicals, but when 5 million gallons of water are used, 1% of that would equal 50,000 gallons of chemicals. So there are still tens of thousands of gallons of these chemicals going into the ground every time they fracture. A large amount of silica sand is brought in trucks as well. This sand is very fine, like a powder, not like the typical beach sand that you're used to. Sand mines exist all over the state, but only a couple existed before 2004. Since then, 14 new sand mines have been permitted, with 9 of those being permitted in just the last 3 years. These mines are very damaging to the environment as they are just surface strip mines. This picture was from an ADEQ violation report of a fluid discharge from a sand mine into a creek in the area. Since the sand is so fine it blows easily in the wind, this type of sand is the cause of silicosis. Silicosis is an often fatal disease of the lungs that is not uncommon in people who work with this sand. Employees in the industry who work around this sand are supposed to be fitted with special breathing devices as required by OSHA, but often they are not. This can also be a health hazard to people living near sand mines and processing plants, as well as those who live near wells that are fracked. Before the fracturing process begins, explosives are lowered into the hole to blow small holes in the steel pipe and concrete casing that is on the horizontal portion of the well. These holes allow the fluid that is pumped in to flow out of the pipe and into the rock, and then allows the gas to flow back from the rock into the pipe to be collected. After that, the fracturing process begins. This part of the process is probably the loudest part of the process. Depending on the length of the horizontal part of the well, the fracturing usually lasts 1 to 5 days. During this process, the water, sand, and again 20,000 to 50,000 gallons of chemicals are mixed together and pumped into the hole at extremely high pressure. The pumping pressure is usually 3,000 to 8,000 pounds per square inch, and sometimes even more. This creates the cracks in the rock and crushes the shale that releases the gas that is trapped in small bubbles in the rock layer. The sand holds the fractures open to allow the gas to flow back through the cracks and into the pipe. The well is usually fracked in sections until most of the horizontal portion is covered. Once the well is fracked, the gas must be collected. Natural gas is methane. Initially the gas is dirty, which means it has dirt, sand, water, and fracturing fluids in it. It must be vented or flared before it can be sent down a transmission line to be refined. Venting is when a gas is just released into the air, and flaring is when it is burned. Flaring is the better of the option because when natural gas is vented directly into the air, methane is over 20 times more potent of a greenhouse gas than carbon emissions. A Cornell University study in 2011 showed that up to 8 million cubic feet of gas was vented or flared from each well. That's enough to fill about 40 Goodyear blimps, or almost 3 million balloons. When the gas is vented, it contains all of the chemicals used in fracking, as well as other harmful underground substances. These things are misted into the air and can drift towards homes, farms, and other things in the area. This can be harmful to people, livestock, crops, and wildlife. Gas wells can also release a gas called hydrogen sulfide. This is another gas that is extremely harmful to humans. As has happened in Arkansas, one full breath next to one of these wells can send a person to the hospital, and much more of an exposure can be fatal. Often a windsock is placed at these wells to show workers which way the wind is blowing. That way they can avoid staying downwind of the site for too long. Homes and farms may be nearby. Residents in the area are never notified, and signs indicating the danger may not be put up for days. Some residents near these wells have concerns for their cattle, horses, pets, and wildlife in the area because animals can't read signs. Once the well is producing, you then have a typical well pad. All well pads do look slightly different, but mostly are the same. Large tanks and pipes, all and other pieces of equipment all over the site. These are all typical well pads from the Fayetteville Shale area. And as you can see, many are in areas where there's farms. And keep in mind that all the steps in the process we've shown you up to this point are only required to be done 200 feet from people's homes. This piece of equipment is what is commonly referred to as the Christmas tree. It is the part where the gas flows out of the ground and down some pipes to other pieces of equipment to be refined and dried out. Notice the solar panel. In areas where there's not a close electricity source, solar panels are used to power the equipment. We're using solar energy to obtain our fossil fuels. A large portion of the fluid that is injected comes back to the surface, and it is separated out from the gas and flows into large tanks on site like these. Some gases produces in liquid form called a wet gas. This liquid is collected in large condensate tanks that also emit harmful gases themselves. You can see the windsocks above these tanks, again to show workers in the area which way the wind is blowing so they can avoid staying downwind for long periods of time. There can often be homes and other buildings in these areas. We also often see pieces of equipment that have been spray painted on site with paint sprayed all over the ground. A portion of the gas that is released during fracturing is not recovered from underground and seeps up towards the surface. The Cornell study I mentioned earlier estimated that about 2% of the gas that was released during fracking was lost into the atmosphere from the ground, through leaky pipes, and from venting and flaring. A more recent study by the National Oceanic and Atmospheric Administration, or NOAA, estimated that about 4% of this gas was lost to the atmosphere. Natural gas is often touted as a clean fuel or cleaner than carbon emissions, which come from oil and coal. However, when natural gas is not burned and is released or escapes into the air, it is over 20 times more potent of a greenhouse gas than carbon emissions. Gas released from underground and from leaky pipes can also kill trees and other plants. The state of Massachusetts has spent millions of dollars over the last few years replacing trees killed by leaking pipes. This picture shows an orchard that is across the street from a natural gas well that is also on a cattle farm. Gas wells also emit other harmful gases from the various parts of the well, from glycol dehydrators, condensate tanks, and even fluid pits. There are also other gases from different parts of the operations, like compressors, generators, and truck engines. Along with methane and hydrogen sulfide, other harmful gases like benzene, toluene, xylenes, ethylbenzene, which is BTEX, organic chemicals, nitrogen oxides, sulfur dioxide, carbon monoxide, formaldehyde, metals, naphthalene, acrolein, propylenes, xylenes, and hexane have been found in areas of gas drilling. These studies I mentioned earlier by Cornell and the University of Colorado at Boulder, NOAA, and the EPA have shown that air pollution in parts of rural Wyoming and Utah is worse than that of the city of Los Angeles from gas drilling in the area. Another study done by Eastern Research Group that was contracted by the city of Fort Worth, Texas, showed that air pollution from natural gas drilling in and immediately around the city was more than the air pollution from all of the vehicles in that same area. Air quality studies have yet to be done in the Fayetteville Shale area, but results could be expected to be similar. The Arkansas Department of Environmental Quality has told us that they do not have the proper equipment to monitor air quality in the area. Many people have heard of water issues associated with the industry, but the air pollution is as bad or even worse of a problem than water issues right now. Residents we have talked to have complained of things like dizziness, headaches, sore throat, eye irritation, rashes, nosebleeds, fatigue, and many types of respiratory problems. All of these things are known symptoms to exposure of all of the gases that are present near natural gas activities. Although many things can cause these symptoms, many people report never having problems like these until production starts in their area. Many of the gases present are also known to cause cancer. As I mentioned earlier, windsocks are often present at gas wells and compressor stations, so workers can avoid staying downwind of these things for long periods of time, yet homes or cattle or horse pastures may be nearby. Some well pads have small compressors on the pad themselves. However, pumping stations called compressor stations are required about every 40 to 100 miles of pipeline to pump the natural gas down the transmission lines. There are over 100 in the Fayetteville Shale area alone. Obviously, as with many steps in the process, all the pieces of this facility must be trucked in on large trucks. Some compressors are smaller facilities and indoors like this one, and this one here with only 2 compressors. Some can be quite large and are outdoor facilities like this one with 4 compressors. This one here has 6, and we found some with up to 8 compressors in the area. These stations emit a lot of dangerous gases themselves, much more than what one gas well would emit. They are a danger to the health of residents that live close and contribute to the overall air pollution in the area. They are also very loud. Sustained sound levels have been measured at 90 decibels outside homes near compressor stations. The AOGC enacted a rule that limits sound levels outside nearby homes to 55 decibels. Once the rule was enacted, companies had 1 year to come into compliance, which would be the summer of 2012. A provision in the rule says that companies that build new compressor stations have 1 year after the station goes into operation to come into compliance with the rule. Here's a map of all the compressor stations in the Fayetteville Shale area. As you can see, there are over 100. Thank you to Greers Ferry Lake Natural Gas Watch for developing this map. They can be found on Facebook.com at Greers Ferry Lake Natural Gas Watch. After the well is fracked, anywhere from 10 to 70% of the fluid comes back out of the hole. This flowback fluid is called produced water. Some in the industry simply call it brine, but this is somewhat misleading. Most of the time what comes out is less than half of what was put in, but that depends on the underground geology and how much was injected. This is still a very large amount of fluid that has to be disposed of. Initially, the flowback fluid flows into trailers or the pit on site immediately after fracking, but once the site is completed and the flowback rate slows, the fluid usually goes into these large storage tanks on site. There's usually 1 or 2 of these on a pad, and a berm is required around the tank to hold fluid in place in case there were to be a rupture of the tank. Sometimes this berm is gravel, sometimes it is metal. These berms are supposed to be large enough to hold at least 75% of the fluid from the tanks, but often they are not. They can also erode over time, becoming ineffective. Here's a picture of a tank that has been leaking. This fluid must be pumped from these tanks into trucks to be taken away for disposal. These trucks are everywhere in the Fayetteville Shale area, 24/7. You will pass one every minute or so on just about any highway in the area. As I said before, some of these trucks may be carrying fresh water or pure chemicals in them, but most of them are carrying the flowback fluid. Again, all of these trucks are destroying the roads at an incredible pace. Even if the severance tax is raised, it still won't be enough to pay for the damage to our roads, and taxpayers from all over the state will end up paying to fix the damage. With this many trucks on the road, no matter the industry, there will be more accidents, which means more injuries and deaths in the area. This driver turned out to be okay. I'm not sure about this driver. I wasn't able to hear. We hope he was okay. These trucks must be maintained and washed from time to time. We have observed employees climbing into the tanks to wash them out with no protective equipment at all. Truck washes are also required to collect and dispose of the water that they wash the tanks out with, but some have been caught letting it flow into ditches and storm drains that lead into waterways. Sometimes these trucks have misleading words on them like this one. We're unsure what is environmental about these fluid disposal trucks. Here is a picture of some large temporary storage pits in the Fayetteville Shale area. These pits are used to temporarily store this fluid until it can be taken for disposal. You can see the size of these pits compared to these vehicles that are here on the road along the top of the pit. One of the ways that this fluid is disposed of is at sites called land farms. A land farm is a place where this fluid is dumped into a pit and then it is sprayed out into a field with large agricultural sprinklers. Sometimes this fluid is sprayed into cow pastures or adjacent to a field of corn or wheat or rice. Here's a map showing all the land disposal sites in the Fayetteville Shale area. The most common type of disposal for this fluid is at a disposal well called an injection well. These wells are generally no deeper than most gas wells. The shallowest injection well in the state is only 2,500 feet deep. Most inject fluids into the ground at multiple depths. First, this fluid is dumped into a grate on the ground. Under this grate is a culvert that leads to a storage pit on site. Sometimes underground concrete tanks are used, or large above-ground storage tanks. This fluid is then pumped into the ground at high pressure by large pumps. Some disposal wells have a large number of storage tanks, and as you can see, not all disposal wells look alike. Notice this one right next to the Damascus water line. In southern Arkansas, the ground is generally made up of a thick clay, so a plastic liner is not required in these pits. The fluid pits are usually much larger than they are in the Fayetteville Shale area. These pictures are of typical holding pits in southern Arkansas. Most of these disposal wells inject 200,000 to 500,000 gallons of fluid per day, every day, 365 days a year. Some have been operational for over 6 years. This fluid can travel great distances underground. This is a map showing where fluid that was disposed of in this injection well here at the bottom of the screen ended up in 2 of the production wells on this well that was over a mile away. The AOGC forced the company operating the disposal well to seal off the top injection level, and the fluid stopped migrating. Oddly, the company reapplied later to be able to start injecting at a shallower level again, but the request was denied because of complaints from the company that owned the production well in the area. When a well is no longer producing enough gas to be profitable to maintain, it is then plugged or filled with concrete. This can cause problems in the area with methane migration as well. Once the well is plugged, the leftover methane underground will find another path to the surface, which sometimes can come up in, again, people's water wells and homes, thus causing explosions and fires.